Hey everybody, welcome to episode 9 of Building Jam. In this episode, we have a very special guest, Hui, who's one of our engineers, and we talk about what we're doing about artificial intelligence at Jam and what the future looks like. So let's get into it. It all started when Hui was demoing something during stand-up for all the things that he has been like cooking up. Like, Danny, do you want to talk about that a little bit first? So people who are listening have like the context of what we're talking about.
Yeah, so here's the context window. I'm just kidding. Last year, we added an AI assistant to Jam that helps engineers debug a little bit faster. It like saves you from having to search Stack Overflow, open up 100 tabs. It's like we prompted this AI with everything we know about the bug in the web application, then it offers you some solutions. And if you give it some code, it can even fix the code. And so people are using it. It's exciting. It's like a hint towards where we think the future is headed. And then Google announced Gemini with their 1 million token context window. And we were super lucky and got early access, and Hui was the engineer to get to play with it first. And fast forward to a demo Hui did earlier this week for the team that blew us all away. And that is what led to this conversation right here. We're like, what's happening at Jam this week? This is the only thing we want to talk about. So maybe Hui, what are you up to?
Well, it's interesting because my to-do list is enormous. There's no way I could tackle it myself, I think. But I think it might be worth sharing, what is our principle and what is our approach to this kind of project, right? I think there was an interesting discussion when we were trying to figure out how we're going to leverage this thing. And Danny, you mentioned something that was really interesting in that we should strive to use this to provide a leap forward, right? Instead of an incrementally better solution. So instead of just trying to generate better repro steps, let's be as ambitious as possible with what we currently have. And I thought that was really cool. But that so we want to leverage this thing in this leap forward kind of approach. But then this brings up another problem, which is, let's say we want to make Jam generate a fix for you. So if you found a bug, we can generate a fix for you, like an actual fix. A person could argue that if a software is able to actually do that consistently, through the entire input space, we achieve AGI, right? Because essentially that's what we do. It's look at a problem and then figure out all the steps that we need to take until we figure out what's wrong and how to fix it. So the industry approach, I think, for this sort of problem, it's okay, so then we need to narrow the problem space, right? We're not going to solve every single problem. We're not going to try to do that because we're bound to fail. So we've picked a very specific, well-defined scope that fits with our UI paradigm, which is something that captures a screenshot or a screen recording. And with that, in this narrow space, we have much better odds of succeeding. And because I think the crux here, and I think that's the problem where all teams are facing that are implementing this kind of project, is the real utility of the solution, right? Because an LLM is kind of it's super unreliable. So how can you derive and take utility out of it? So that's one way we can help ourselves in that direction.
I think you talk about the input spaces, and I think that the thing that is really interesting that you mentioned is how do we limit the input space, screen recording or screenshot, and find utility from there instead of attacking this vast sea of different problems and solutions that for example, what a lot of companies I see that are doing are they will create their own like VS Code like plugin or like an editor where they can just like create and generate a lot of code, which it seems a much harder problem to solve because it's just not there yet, right?
Yeah, exactly. Yeah, and I think this is something that the industry is gonna go through as a whole, right? Because there's all this hype, but like the companies that are really like making money out of this kind of solutions are very like you can count in your hand. So like there are a lot of bets, but all these companies are going through like this process of like how can we reliably produce value, which is like anecdotally this is very similar, not in scale of course, but like back in 2016 I think there was like this wave of chatbots with IBM and Watson being like the lead. There are this whole like all these companies bringing up these AI tools, which they weren't LLMs, but like they used earlier versions of like the GPT in the product. But like I'm sure you've all have experienced like an interaction with the chatbot, right?
I not only experienced it, I was a big advocate for it. So in 2016, when I was working at Retail Minot, and they sent me to the Facebook conference. So there was no Meta before, like it was a Facebook conference, and they just acquired a company. I forgot their name, but it's a French company, and they were doing some really cool stuff with natural language processing. And their whole thing, like all I did was attend all of the sessions to like build these like chatbots. And like when I came back to the company, I was like, yo, we have to help like people buy coupons through chatbots. Like this is the future. In reality, it wasn't that great. Like I used it and I was like, is this what it really is? Like other than just like it almost felt like a very limited flowchart kind of problem solving.
Exactly. A decision tree very like very fixed, kind of like a way of operating. A solution looking for a problem kind of thing.
Can you talk about like what it actually looks like for you to be like trying things out? Like you've built a bunch of internal tooling around it. You're doing all these experiments. What does this actually look like?
So I think that the crux of where I am right now is I need to be able to have more confidence in what the thing that the model produces, right? And essentially that's you could argue that's a reliability aspect of things, right? So for these LLMs, reliability, it's kind of like the reliability of the infrastructure. So like, do I get a response back, or does it, 504 or 500 or timeouts or whatever? And there's also like the reliability in terms of like, is the response that I was looking for? And all these prompt engineering and techniques, these are all ways for dealing with this other type of reliability, right? Where you're like, I want to get what I want, but I need to do all these sorts of like hacky things to get there. And so what I realized was like, I need a way to work on that reliability side of things as iteratively as possible. So like the iteration cycle should be as quickly as possible. So I tried all these like popular open source tools like LangChain, the family of LangChain kind of stuff. But I kind of felt like that was somewhat limiting for what we're trying to do, because like our use case is not a one shot or a zero shot kind of way. We need some sort of like planning and reasoning so we can actually generate useful stuff. So that's where I spent most of the time, is like, how can I iterate faster? And that boiled down to like trying to figure out where this problem happened before in the industry and try to like adapt those ideas into what I'm currently doing. So for instance, one of those is if you're building infrastructure in a team, you're likely using Terraform or something like that, because it's kind of like a reproducible way for you to deploy services. So like I can use that, and like as Ernesto mentioned, I was that guy also. I was bitten by this chatbot bug back in 2016, 17. And this was this company called Raza, which built this open source library. And I was very engaged and driven by them. And like in hindsight, what they're trying to do is essentially what we do right now. But they didn't have the means, and it was more structured. So like essentially in a nutshell, so I don't spend 30 minutes talking about Raza here, but it was like this open source chatbot library. And the way that they solved the problem, which was novel, at first it was open source. And the second is they used LLMs not LLMs, but they used ML models in two parts of the system. So one is the dialogue, which was what was Ernest was talking about. So they defined the dialogue, but they defined the dialogue as text files. So they would train a model to try and generalize over the dialogues, and then they would use AI as a natural language understanding for like when users say something or type something, you use that to try to classify what they're saying. So you could, understand what they're saying, and then you map that into like a decision, a policy decision model that decide what needs to do next. And it's kind of like what we're trying to do right now, right? We have this problem, and we kind of need to take steps to get there. So like through these different inspirations, I've come up with a way that help me like iterate faster in this problem.
I'm curious about the classification of bugs and where like the classification of like where we can be most helpful and like where AI is at in helping us solve certain types of bugs, because people are using jams for all these different use cases, whether it's like a feature suggestion or, like there's all these different ways you could do it. But I'm curious about the actual classification of the jam being that we're using AI with.
Yeah, it's a very good question. So if you're looking at the what there is out there for like, I want to use AI to solve bugs for me. So for that use case, the most common way to go about this is like what Facebook has done, and there are some other companies, but like the one that published papers about this was Facebook, where they have this LLM that kind of crawl repos and try to produce fixes kind of like in the background, right? So you have a repo, and then you connect an LLM to your repo, and then it'll try to find bugs in there, just looking at the code. But our approach is different because we have a UI that users can generate a signal of what the problem is. And that's really useful because like we have access to the source, but you also have access to this very contextual information, which is like the bug is here, and this is what I want you to fix. But to answer your question, so we're not applying this to every another jam, right? Because jam is used in a variety of ways. And if you try to use that in all jams, then it'll produce a bunch of garbage. And so right now there's like, if you want to use jam like that, you need to instruct it. So like, this is the part of the app that I found a bug or something that I want to fix, and then you instruct it, kind of like what you see as these LLM applications, where like you instruct what you want it to do, and then it from that on it try to figure out what needs to be done. This was fun. Thank you.
Yeah, thank you for coming on.
For us. Thank you.